So in this video I'm going to be explaining the concept of cyclic sort. You normally land on such a problem where you're told you have a sequence of numbers but they are not in order. So for example, 5, 3, 1, 4, 2. The key characteristics is that the numbers must be in order, they must be sequential, and it must cover all the numbers within that particular range. So for example, in this case, because we had a 5, so for the total number of total of 5 items, we have all the numbers, but they're just not in order. So the reason why this is an important problem is because these numbers might actually be pointing to, they might actually be objects or something of that sort. So you can just implement a normal kind of, you can just like use the native sort and you have to work through it yourself. So how would such a thing look like? Well, firstly the easiest or the brute force approach would be to compare each number with every other number and then put the number in the right place. So for example, I'd just create an array like this, an empty array, and then I'd go in and I'd look. I know the first position should be 1, so on point 0 should be 1. I'd look for it and I'd put it in. Then I'd go through the array again and find item number 2. Then I'd go through the array again and find item number 3, and so on and so forth. But this is a very ineffective problem, a very inefficient approach. In fact, it's going to be an on squared kind of operation, and we don't want to do that. There's a very easy way to do this, which actually means we can do it in place. That means we end up having like an O of 1 space complexity, end up with an O of 1 space complexity and an O of n in terms of time complexity. So this means we just go through it once, and the big idea behind that is we can take advantage of the fact that we know all the numbers need to be there. So the approach would be just taking my numbers again. The approach would be, we basically start from position 1. So in this case, I would go in and put a pointer. So I'm going to introduce two pointers. So I'd put in a pointer there, which is our current position, and then I'd put in another pointer where that number should actually be. So for example, that number should be there. So once I have those 2 pointers, I'd swap those numbers. So in this case, I'd swap this and this, but now I'd have 5 here, then I'd have 2 here. Once I've done that, I then need to check again. Actually, I've done the wrong thing. So this would now be 2, this would now be 5, this would now be 2, this would now be 5. Then I'd check the next thing, which is this number in the right place? We know j is now in the right place, but now we move the j back, right? So is this number in the right place? Where should it be? It should actually be here. So I put j there, and then again I implement a swap. That is, I don't move from this place until when it's actually working and they have the correct value. Then I'd go ahead and swap again. So now this becomes 3, this becomes 2. Again, I continue staying there, but I now move the j. So the j moves here. So when the j moves to this point, again I execute a swap. So in this case, this becomes 1, this becomes 3. And now at this point in time, this is in the right place. And now what do? I move to the next number. Is it in the right place? Again, it's in the right place, and I move to the next number, and so on and so forth. Now we have been lucky in this case that this has worked in the first without us having to move to the second or third items. There are situations where that wouldn't have been the case. Now we have this kind of operation. The question is, how would this look like in code? So let's think about it. So maybe I'm not even sure whether I remember the original order, but it doesn't really matter. So that's our example code again. Now a couple of things that we do know is we're going to need our i's and j's. So we know I is going to start at 0, j is also going to start at, okay, j is going to be invalid, so that's okay. So I leave it like that for now. So we want to go through this whole loop, and we only want to go through the loop but only advance if the conditions have been met. So I'm going to introduce a while loop. While is usually really good for such kinds of problems. Then I'd say while I is less than the length or whatever. Let's just call this nums, less than nums. Okay, so now we have our value now. So while I is less than nums, we are going to continue. So then the question is, why, at what point do we advance I? So we advance I if I and j are the same, right? So if we put the I pointer there, where is the j pointer going to be? So let's think through that. So the j pointer is actually going to be at the position where we should expect this number to be. So it's going to be at nums whatever I is. However, because it's an index, we need to take it back, right? Because Python, here I'm writing this code in Python, usually 0-based index. So I do num I minus 1. Okay, so now I know where j is. Now if I and j are in the same place, that's awesome. As I talked in this example, if I and j are in the same place, then just advance I. So then I'd say if the value that I got here, right? So basically if the num I is equals to the num point j, then of course we continue, right? So we can do I plus equals 1. So the number we continue on. However, if this is not the case, then we need to swap those numbers. So we swap. So we num I, num j, right? And then what we want to do is we want to swap those numbers together. So num j and then num I. Awesome. And yeah, so this will continue until the end. So if I started out with nums here, if this was nums as was set, and we started the execution, then we should get to a point by the time the while loop is over, this entire thing should be sorted, and then you can go ahead and return the nums. So I thought that was a neat way to do the sorting. It's called cyclic sort. Thank you.